NASA, the National Aeronautics and Space Administration, presents the Space Story. How will the comet end? With a bang or with a whimper? That's what astronomers around the world are wondering. They're anxiously awaiting this month's collision of comet Shoemaker-Levy 9 with the giant planet Jupiter. For 5 days, beginning on July 16th, the nearly 24 pieces of the already disintegrating comet will enter Jupiter's atmosphere at blazing speeds. Astronomers have known the crash was coming ever since the comet was discovered more than a year ago, but no one is quite sure what effect, if any, the impacts will have on a much larger planet made almost entirely of gas. Part of the difficulty, says comet co-discoverer Eugene Shoemaker, is that we don't really know how solid these fragments are.
Our state of knowledge of comets is primitive. We've never gone and gotten a direct sample of a comet and brought it to Earth. We don't even really have any good images of comet nuclei. We sort of have a silhouette of comet halley. There are all kinds of models and ideas about what a comet is made of. We know they're made of ice and rocky material in some proportions that are about the same, but we don't really know how a comet nucleus is put together. Is it just a rubble pile? Is it a fluffy snowball? I suspect comets actually are idiosyncratic. They're individualistic. If they really are pieces of bigger things, which might have grown big enough to differentiate, one comet will be different from another comet.
One way to determine how big the comet fragments are and what they're made of is to watch the flashes they make as they enter Jupiter's atmosphere. Unfortunately, even though practically every telescope in the world will be watching, the view from Earth will be lousy. The actual point of impact will be on the opposite side of Jupiter as seen from our own planet. Only the Galileo spacecraft, now en route to Jupiter, will be able to watch the collisions as they happen. And what will Galileo's cameras see? Once again, the theories vary, says project scientist Torrence Johnson.
I think that if one or more of these fragments that we are measuring has a size of typically around 1 kilometer or 2 kilometers, and it's fairly coherent, that is, it isn't just a rubble pile, we would expect some pretty dramatic phenomena that we would expect to see in the camera. First of all, a very bright meteor lasting from a fraction of a second to, say, a couple of seconds, which would appear like a bright star just on the dark side of Jupiter as seen from Galileo, that would suddenly brighten up and then fade down.
And if the comet fragments do turn out to be kilometer size or larger, the spacecraft may see more than just meteor trails.
A body that size won't burn up in the upper atmosphere completely. It will continue to plunge on down through the cloud decks of Jupiter, creating a monstrous explosion when it stops below the cloud decks. And so tens of seconds after we see that meteor, we might expect to see another large red fireball rising up from underneath the cloud decks of Jupiter. It would still appear as a point of light to the spacecraft, but it would last a lot longer. That might last as much as a minute or more.
This is the first time in history that scientists have known about such a cataclysmic event in advance. But there is plenty of evidence that comet and asteroid impacts happen frequently by cosmic standards. In fact, says Shoemaker, a collision may have played a crucial role in our own species' development. After a large impact did in the dinosaurs 65 million years ago, a whole host of new species arrived on the scene, including mammals and eventually humans.
So comets are of interest because they have stimulated evolution, basically. But they're also of interest in that it's the comets early in the history of the solar system that delivered the water, that delivered the constituents of our atmosphere to the Earth, and maybe even delivered the starting organic chemicals to initiate biological evolution. So we are, in some sense, in my view, we are the progeny of comets.
And speaking of progeny, don't feel sorry for Eugene Shoemaker and his wife and fellow scientist Carolyn that they're about to lose one of their comets. Between the two of them, they have at least 30 more celestial objects to their name. This has been The Space Story, brought to you by this station and NASA. For the National Aeronautics and Space Administration, I'm Bob Tebow.